Some logarithm functions can be drawn using translations of previous graphs. How do we get a basic log function to graph f of x equals log base 6 of x plus 3? So in this case, we want to shift the basic graph, which is y equals log base 6 of x, to the left 3. When we have an addition inside of a function, you shift to the left that many units. So here we have the log base 6 of x, and we're going to shift it to the left 3 to get the green graph. How do I use a basic log function to graph a log base 6 of x minus 1? Well, you start with a log with y equals log base 6 of x. And you want to shift that down by 1 because we're subtracting 1 from all the y values. So we start with y equals log base 6 of x, and we move everything down 1 unit. The two most commonly used logarithms are the common log, that has a base of 10, and the natural log, that has a base of e. Because of that, we have shorthands for both of those. The log base 10 of x, we can just suppress the 10 and write it as log of x. And the natural log, that is the log base e of x, is written ln of x. You have a button on your calculator for both of these. Let's evaluate some logarithms. What is the log of 1 million? This is the common log. So if you don't see a subscript, that's the log base 10 of 1 million. This is the exponent on 10 that gives a million. What's the exponent on 10 that gives a million? Well, there's 1, 2, 3, 4, 5, 6 zeros. So this is 10 to the 6th equals a million. So the log base 10 of a million is 6. What is the log base 3 halves of 8 over 27? What's the exponent on 3 halves that gives 8 over 27? Now 8 over 27 is 2 to the 3rd power over 3 to the 3rd power. So that's the same as 2 thirds to the 3rd power. We want to know what 3 halves to what power is equal to the right. So negative exponents give you reciprocals. So this will be 3 halves to the negative 3. So the exponent on 3 halves that gives 8 over 27 is negative 3. Let's evaluate the log base 6 of the 3rd root of 36. So what's the exponent on 6 that gives the cube root of 36? Well, the cube root of a number is that number to the 1/3 power. And 36 is 6 squared. So 6 to the 2/3 is the cube root of 36. So the exponent on 6 that gives the cube root of 36 is 2/3. Let's evaluate the natural log of e to the third power. And then this is just shorthand for the log based e of e to the third power. What's the exponent on e that gives e to the third? That's 3. Here we have 4 times a common log of 1,000 equals x. If we solve for the logarithm, we get divide both sides by 4. This cancels with this. And I get the log of 1,000 equals x over 4. Converting to exponential form and realizing that when you suppress the base, you have a 10 here. This is 10 to the x over 4 equals 1,000. 1,000 is 10 to the third power. Since exponentials are 1 to 1, this has to equal this. So we have x to the fourth, or x over 4 equals 3. To solve for x, I multiply both sides by 4. This cancels with this, and I get x equals